Hello, sir. Hello, fellow student. I am Savinishan Navalan. I would like to introduce my other teammates, Amir, Danish, Rafi. Today, I would like to share our mini project about water level indicator. We will starting from introduction with Amir.
The purpose of this mini project is for the need for simple and reliable method to monitor liquid level is prevalent in various applications, from household tank to industrial processes. This mini project focuses on the design and construction of a water level indicator using basic electronic component. The purpose of this project is to create a clear and immediate visual indication of different water level, low, medium, high, and overflow using light emitting diodes LED activated by water level sensor and discrete digital logic. This system aims to provide a straightforward and cost-effective way to monitor water level without the complexity of programmable devices. Now I am gonna talk about objective of the project. The primary objective of this mini project are to design and build an electronic circuit that senses for distinct water level, low, medium, high overflow. Secondly, to provide a direct visual indication of the current water level using LED. Third, to utilize discrete electronic components such as water level sensor, D flip-flop for signaling conditioning, logic gate, and gate for level indication, and LED. Four, to construct and test the circuit on a breadboard or prototype board. Five, to document the design, construction, and testing of the water level indicator.
Activity conducted. Component research and selection. We research various type of water level sensor suitable for this project. We also review datasheet for D flip-flop and gate IC, resistor, LED, and buzzer to understand their functionality and connection requirement. Circuit design. Interfacing the chosen water level sensor to the input of D flip-flop for synchronizing and potential debouncing. Using NGAT to implement the LED control logic. For example, the medium LED will be on if the medium sensor is active. Breadboard and wiring. The design circuit was made on a breadboard. This involved carefully placing and connecting the IC sensor resistor LED and power supply wire according to systematic diagram. Testing and verification. The circuit was tested by simulating different water level and observing the corresponding LED indication. The functionality of the sensor signal condition and the LED control logic was verified. The current draw of the LED was checked to ensure they were within safe operating limits. Number 4. Result. Visual water level indication. The reconstructed circuit successfully illuminated LED to indicate different water level. When specific water level sensor is activated, the corresponding LED turn on. Circuit photo made in quarters. Observed output showing in waveform type. This circuit was I follow the quarters diagram and made in Tinkercad software.
For the discussion, the constructed water level indicator using discrete electronic components provide a basic yet functional way to visualize different liquid levels. The use of D flip-flops helps in synchronizing the sensor signals and provides a degree of debouncing, leading to a more stable indication. The AND gate logic allows for straightforward implementation of the LED control, where higher water levels typically results in more LEDs being illuminated if a cumulative indication was chosen. This approach is limited by the number of discrete components and the complexity of the logic that can be easily implemented. For more advanced features, a microcontroller or an FPGA will offer greater flexibility and integration. The accuracy of the system depends on the reliability of and placement of the chosen water level sensors. For impact of the project on the community, Potentially, even a simple water level indicator like this can have a small positive impact. So for educational value, it serves as a hand-on learning tool for understanding basic electronic circuits, sensoring, interfacing, and digital logic. For simple monitoring solutions in very basic applications where only visual indication is needed, such a circuit could provide a low-cost monitoring solution.
Obviously, if necessary, the novelty of these mini projects within the scope of basic electronics will likely lie in the specific combination of choosing sensor, the implementation of the signal condition, using the flip-flop for demotion and synchronizing, and the logical arrangement of get the drive, the LED for a clear water level indication. Well, in the individual component and techniques are standard integration to achieve this particular functionality can be considered the project unique aspect, especially within an educational context. In conclusion, this mini project successfully demonstrated the design and construction of a water level indicator using discrete electronic component. This can provide a visual representation of different water level through the elimination of LED based on sensor input conditioned by the flip-flop and controlled by logic gate. Future work could explore such as implementing more robust devices circuit for the sensor, using different type of sensor for improved accuracy, or the ability to measure continuous water level. Adding an auditory alarm for critical water level using a buzzer or other sound generating component, designing a more compact and user-friendly physical enclosure for the device. Investigating the use of a microcontroller to add more ambient features like displaying the excess water level or sending alerts. Okay, remember to relate this session to the specific of your project and the component you actually use. Good luck with your report. Bye bye. Say oh.